All right, you got one substance and then you got another substance, and then they come together and they combine and form a new substance. How do you know what that substance is? In this video, we're going to try to predict some products when substances combine together. And what you should have is this URL, this tiny URL that leads to this website right here. Just scroll down to the bottom for predicting products and click on begin quiz. We're going to use our chemistry knowledge. Hopefully you remember things about the charges of ions because that's really important. If you haven't practiced naming ionic compounds, then I really encourage you to take a look at that playlist to learn how to name ionic compounds because you got to really know your charges for you to be successful here. So in this activity, we got 5 reactions. I'm just going to go through them and try to help you out so that you can try it on your own. The questions will be random, so you can try this multiple times until you kind of get the hang of predicting the products of a reaction. What we have on the left-hand side, these are called the reactants of a chemical reaction. On the right-hand side of the arrow, we're going to have 4 possible choices to choose from. These could be our potential products, but only one of them is correct. We're also going to be using perhaps these 2 resources. One is called the activity series, which we've already learned before. And the other resource is called a solubility table, which we have not touched upon yet. However, it's very easy to use. On the left-hand side of our reactants, you're going to notice that in parentheses, we see something that's written AQ for both of these substances. Now, AQ just means aqueous, and a substance that is aqueous just means that it's dissolved in water. That's all there is to it. Now, sometimes you might see the letter S also, which means solid. L, you can probably guess what that is, liquid, and sometimes it is G. Can you guess that? Gas. We should know also that these reactants, they are magnesium chloride and also sodium carbonate. Since they are aqueous, they dissolve in water. All right, so I'm going to look down here on the bottom. This beaker shows you what those ion charges are if you don't know them. So the magnesium chloride breaks down to Mg positive 2 and Cl negative 1. The sodium carbonate breaks down into Na positive 1 and CO3 negative 2. Okay. Now, what's going to happen when these ions are all dissolved in a beaker? Well, they're going to want to recombine, and they do not want to combine to be the same thing again. That would be pointless. So what's going to happen is that basically all of the positive ions, they're going to want to swap places with the negative ions. So, for example, MgCl2, there was an Mg positive 2 ion. It's not going to be with the Cl ion anymore. It's going to be with the other negative ion. That would be the carbonate ion. So the first product would be magnesium carbonate. What would the second product be? Well, there's also the sodium ion. The sodium ion is no longer going to be with the carbonate ion. It's going to be with the other negative ion, which would be the chloride ion. NaCl would be our next product. Okay, so we have 2 products here. One of them is magnesium carbonate, and the other one is sodium chloride. Okay, for magnesium carbonate, it's written like this if you balance out the charges. And for sodium chloride, it's written like this if you balance out the charges. Now, what are the states that these substances are in, these products are in? Well, you're going to look at our solubility table. So again, our first one is magnesium carbonate. So you look to use this solubility table, you look at where we have magnesium and where we have carbonate. Where do they meet? Magnesium carbonate is right here. You see this S? That means magnesium carbonate is a solid substance when it forms. Okay, so it's going to sit on the bottom of a beaker most likely, and it's going to be solid. The other substance is sodium chloride, and you probably already know this one, but let's use the solubility table anyways. Sodium is right here, chloride is right here. Find out where they meet. Sodium chloride is right here. AQ, it's aqueous. That means sodium chloride will dissolve when it's in water, which we should already know that, right? That means that our compound is this one. Submit. Nice, we're correct. So you move on to the next page. Now here we are asked to balance the chemical formula that we just predicted. And for the purposes of this video, I'm just going to zoom past this because the objective here is to predict the product. So this is good practice. I actually want you to do it until you get it right, but I'm just going to speed forward through this part of the video. All right, now we've got another reaction. This is the last one I'm going to do. And this one's a little bit different. So let's take a look at what we have here. Now we have copper 2 chloride, which is aqueous, meaning it's dissolved. And we also have it reacting with silver. And this is silver metal, which is a solid, as you know. When you take a look at these two substances in a beaker, you're going to notice that since the copper 2 chloride is aqueous, it will dissolve into its ion counterparts. And since the silver metal is a solid, the silver atoms are all clumped up like a solid. This reaction is a little bit different, but what we should know is that we kind of want to proceed with the same thought process as the last reaction. So we're going to break down the compounds into their ions, and if it's just an atom by itself, I want you to kind of think of the charge that atom would have. So if we look at the beaker below, we should notice that the copper is going to have a positive 2 charge. There's actually a typo in this beaker, but the copper should have a positive 2 charge, and the chloride should have a negative 1 charge. Okay. The silver atom should have a positive 1 charge if it did have a charge. So those that are charged listed. What could potentially happen here is that the positives and negatives can swap places, just like the previous reaction. So the only possibility is if the positive silver swaps places with the positive copper here. So a potential product is going to be silver chloride and copper metal by itself. What we're going to have to look at here is if this reaction actually happens. Will silver replace copper? And this is where we're going to look at the activity series. So I'm going to click right here. We're asking ourselves again, will silver replace copper? Since silver is less reactive than copper, it's not going to replace the copper, okay? So if it's not going to replace the copper, is there going to be a reaction? There shouldn't be. So what we're going to click here is no reaction. Let's see if that's correct or correct. So I want you to try to figure out the rest of the problem. See if you can actually try to get it. If you kind of got the hang of it, that's great. If you don't, that's okay. We're going to actually go in depth with each of the reactions on a later day.